In 50 years analyzing structures, I have never seen physics bent this politely.
This is how engineers stacked an $8 billion ship on top of Marina Bay Sands' 3 crooked skyscrapers. Before the ship, before the towers, there was only reclaimed seabed and a client's impossible sketch. My colleagues called this brief unbuildable before the first meeting even ended. The brief read like a dare: 3 independent towers leaning outward, joined by a deck longer than the Eiffel Tower is tall. My colleagues in that room called it unbuildable before the meeting even started.
This entire plot for Marina Bay Sands did not exist a generation ago. It was pulled out of the sea itself.
Before a single Marina Bay Sands column could rise, we had to understand 30 meters of unforgiving marine clay beneath our feet.
Every layer here tells us how much this ground at Marina Bay Sands will settle under 800,000 tons of concrete. Everything you are about to see began on ground, and engineers were quietly told might never hold a skyscraper. Our answer to the doubt was simple: drive deeper than anyone else dared.
Each pile plunges over 60 meters, deeper than a 20-story building laid on its side.
Get the pile even a few centimeters out of plumb down there, and the whole tower above inherits the error. Nearly 2,000 of these piles now anchor the towers to bedrock, and nobody can see.
We pour foundations at night because concrete this size must cure evenly. Heat is the real enemy here.
Trapped air is a silent killer in concrete. We vibrate every pore until the bubbles surrender.
If the core gets 10 degrees hotter than the surface, the whole slab can crack itself apart from the inside. This single column is where 3 skyscrapers begin, and where our real problem starts.
The architects wanted each tower leaning 52 degrees outward, more than the Leaning Tower of Pisa ever dared.
This jump form climbs itself floor by floor, carrying the tower's own weight up with it. Notice how the columns tilt a little further out with every floor, and it is deliberate, and it is terrifying to build.
A 2-centimeter error on the ground becomes a 2-meter error 60 stories up, so we measure like surgeons.
Every red zone on this screen is a place the structure wants to fail.
Until the deck locks all 3 towers together, each tower leans on borrowed strength from steel props like these.
Every prop here is temporary, but if one fails during construction, the entire sequence collapses like dominoes.
By month 18, all 3 towers were racing skyward, each leaning further than engineering comfort allows.
The ship on top is not poured or stacked. It is welded together on the ground first, piece by piece.
These trusses behave like a ship's hull, rigid enough to span 2 towers with nothing but air beneath the middle.
Every weld is scanned like a hospital ultrasound, because a hairline flaw here could doom the entire cantilever.
Piece by piece, this yard is quietly building the largest public cantilevered platform ever attempted. This single piece alone weighs more than 400 tons, and it still has to land within millimeters of its mark. One miscalculated gust of wind up here and 400 tons becomes a wrecking ball.
Watch the gap close. This is where 3 separate buildings become one single structure.
In structural terms, this gap is the difference between 3 towers and 1 machine. That is the sound of an impossible connection finally becoming real.
This deck stretches longer than 3 football fields laid end to end, floating 200 meters above the street.
Before any joint like this touches the real structure, it must survive a lifetime of movement compressed into weeks. 100,000 cycles simulate decades of wind sway and thermal expansion in a single test. This unassuming steel strip is designed to let the entire deck breathe by nearly half a meter in either direction. Steel expands and contracts with every degree of sunlight, and this joint absorbs that entire dance.
We shake it until we are certain it will still hold when the real wind arrives at full force. A joint this size has to feel invisible under a guest's bare feet, and that is the real engineering victory.
The building sways a little every single day, and honestly, that sway is exactly what keeps it standing. Sensors like this will keep reporting the structure's health for the next century. What looks like solid stone above your head is actually a living structure, constantly adjusting itself.
Entire bathrooms arrive pre-built and get dropped into the structure like drawers into a cabinet.
Every flicker you see is a small victory. Thousands of individual systems finally waking up together. The skeleton you saw rising from mud has become something the whole city now recognizes on sight. Now we build the detail everyone actually remembers, the infinity pool balanced on top of it all. A single pinhole in this membrane, 200 meters up, becomes a leak straight into a guest room ceiling below. That famous edge you have seen in photographs overhangs the tower by more than 3 meters, held by hidden steel brackets. Every one of these brackets carries the weight of water pushing outward, a force most guests floating above never think about. The basin must be level within millimeters across its whole length, or the water itself will visibly tell on us. Even the filtration here has to survive constant wind loading 200 meters above the street. Water is the easy part. It is the concrete cradling it, 60 stories up, that took years to trust. Every tile up here is chosen and sealed to survive sun, chlorine, and wind that never really stops blowing. This optical illusion took more structural math than almost anything else on this project.
What looks effortless from a lounge chair is, underneath, one of the most carefully engineered surfaces on the planet.
Long after the cranes leave, this room never stops watching the building breathe.
Real-time wind data here feeds directly into how the structure's dampers respond in seconds, not minutes.
These dampers act like the building's own shock absorbers, quietly canceling out sway before you ever feel it.
We test every component to loads that we'll never actually see in real life, just to be certain. Every drawing in this binder had to match reality down to the centimeter on a project with this little room for error. Independent inspectors verified every claim we made, because a building this visible cannot afford to be wrong quietly. Every anchor point up here has its own certified rating, because human lives depended on numbers, just like the structural ones. This mock-up absorbed years of testing, so the real rooms upstairs would never leak a single drop. Somewhere in a corridor like this one, the entire building's nervous system quietly hums along, unnoticed. Every test, every sensor, every sleepless calculation led to this quiet, ordinary-looking morning.
Most visitors standing here have no idea they are resting on the largest public cantilever platform ever certified.
It is easy to forget, floating here, that every ripple is resting on 60 meters of piling driven into reclaimed seabed.
3 separate skyscrapers, each leaning further than engineers are usually permitted to allow, now standing as one calm silhouette. At night, this building stops looking like engineering entirely. and starts looking like a promise kept. Every reflection you see rippling across this water took a foundation none of us could see to make possible. From a napkin sketch to a night skyline, the distance traveled here is almost impossible to measure. Every measurement, every cycle test, every argument in that first boardroom led to this exact view. I have studied bridges, dams, and towers for 50 years, and this remains one of the boldest bets I have ever seen pay off. 400 meters of steel, glass, and water, suspended calmly above a city that never stops moving.
Even this single drop of water is, technically, obeying calculations made years before it ever existed.
Structures like this do not happen by accident. They happen because someone refuses to accept the word impossible. You can pick this silhouette out from almost anywhere in the city, and that is exactly the point. Down here at street level, none of the engineering drama above is visible at all, and that too is intentional. Most people looking up right now just see a beautiful building, and they have no idea about the 52-degree lean underneath.
Somewhere in this building, right now, a sensor is quietly confirming that everything is still exactly where it should be.
In 50 years of studying structures like this, I still find myself amazed every time I see it finished. Side by side like this, it barely looks like the same plot of land. These original drawings are kept not as nostalgia, but because future engineers will need to understand exactly what we did here.
This project is now taught in engineering schools as a case study in daring, disciplined design.
Every young engineer who studies this eventually asks the same question I once asked. How did they actually trust the numbers enough to build it?
The answer, honestly, is that trust was earned one test, one pile, one weld at a time.
Nothing about this building was a leap of faith. Every leap had a calculation underneath it.
Standing here, 67 meters past the last column, is still the closest I have ever felt to physics itself.
And that feeling, more than any blueprint, is why we keep building things people once called impossible. This reflection took a foundation nobody can see, and 50 years of accumulated stubbornness engineers like me are proud to call a career. Every impossible skyline starts the same way, with someone refusing to say no. By daylight, the achievement looks almost effortless.
In under a minute, this elevator carries them past 60 stories of engineering they will never think twice about.